Hello. I have not made any videos like this before, but I found this question particularly interesting. I managed to finish it in just under 3 hours, and I thought I'd share my solution. So this is the 451st question in the Quit Off the Drugs Maths Challenge series. It specifies that let AI, BI be pairwise distinct pairs of positive integers for 1 is less than or equal to I is less than or equal to n. Let C be the maximal positive real number such that the following is always true, and asks us to find the floor of 10 to the 6th C. To specify what it means by pairwise distinct pairs of positive integers, the only thing it really means is that A comma B is not the same thing as B comma A, but we cannot have A comma B twice. So let's consider a few cases just to let us become more familiar. The lowest possible value we can get using n equals 5, because we are going for an inequality here, would be 1, 1, 1, 2, 2, 1, 2, 2, 1, 3. Consider n equals 28. This is our optimal combination. Of course, there's a few more likely, but this is the optimal combination I have come out with. So, let us have this proposition. There are n minus 1 pairs that sum to n for all integer n. Here's the proof. Consider k dots. We can divide these up into 2 pairs that sum to k by placing a bar in the middle of these dots. So say if you have 5 dots, you can place a bar in the middle of these dots to put it into a pair of 3, and a pair of 2, a pair of 1, a pair of 4, so on if there's any other ones. So we have k plus 1 elements to work with, but as the question specifies, the minimum value which any value can be is 1, so the 2 on the left and right stay stagnant. They cannot be a bar. So we have k minus 1 elements to work with, and we have one element to choose to be the bar. So we have k minus 1 choose 1 ways to create a sum of k, and thus k minus 1 ways to create the sum of k, and that is the proof. Going back to this, the reason why I chose 28 is because it's 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, which makes it incredibly useful for the specific scenario, because then we can immediately see the result that 1 occurs 7 times, 2 occurs 6 times, 3 occurs 5 times, 4, 4, 5, 3, 6, 2, and 7 occurs once. And this we can generalize. 1 plus 3 plus dot 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 plus n is equal to n times n plus 1 over 2 for all integer n. And for this specific case, it's 7 times 8 divided by 2. So we will take k equals 8, just for the sake of this following proposition. For all x less than or equal to k, where k and x and k are both integers, if the first k plus 1 divided by 2 terms have no complete amount of pairs, or that all pairs that sum to m are present for all n less than or equal to k, x occurs exactly k minus x times. So let's say we have some terms that sum to 3. There are 4 of those. If that is the greatest pair sum, then the amount of terms that must sum to 3 are 4. Or else it would be 4, 2. There'll be 2 pairs. So going back to this, we can rewrite this as that sum of r equals 0 all the way to k of r times k minus r, and thus we can do the same thing to the other side. Then we get this, and by definition of what n is, it's the first n terms, and then the first n terms that sum to k, we can rewrite that as that. Thus, we can get this inequality. And thus, we can get an inequality in terms of C, which says this: the sum of r equals 0 to k of r, k minus r, all squared, divided by k plus 1 over 2, all cubed, is less than or equal to C. And we can see this sequence, as k increases, is actually a monotonically increasing convergent sequence. So when you increase k, it'll increase slightly, it will never decrease, but it will get, the amount it increases gets smaller and smaller and smaller to C, to the point where you can actually take c to be the limit. The limit as k approaches infinity of the sum of r equals 0 to k of r k minus 1 all squared divided by k plus 1 all over 2 cubed. And from there we can just numerically evaluate that. We get c is equal to 2 divided by 9. And thus, the floor of 10 to the 6 multiplied by c is 222,222.